If you think about it, the Earth is kind of like a history book, a really, really long one, like 4.6 billion pages long. And for most of human history, it was written in a language we just couldn't understand. The whole story was locked away in layers of rock, this massive puzzle just waiting for someone to figure it out.
So that's the big question, right? How do we even begin to read this thing? Well, it turns out it wasn't one single breakthrough. It took 3 key discoveries from 3 totally different people to finally crack the code. So let's dive in and see how they did it.
All right, so the very first clue, the first piece of the puzzle, wasn't some grand, sweeping theory about the planet. Nope, it was a simple but absolutely fundamental observation about order. It was like discovering the basic grammar of the Earth's hidden language.
And the person who found it was a guy named Nicholas Steno. Now, Steno wasn't what you'd call a geologist today. He was a Danish monk back in the 1600s. But he had this incredibly sharp, methodical way of looking at the world, and it let him see a simple pattern that, believe it or not, everyone else had just been missing.
So in 1669, Steno laid out what we now call the law of superposition. It's so elegant and simple you'll wonder why no one thought of it before. It just says that when sediments settle and form rock layers, the oldest ones have to be on the bottom. The newest ones get piled right on top. And that's the key. He gave us a direction to read in, from the bottom up.
I mean, look at this. It's just so intuitive when you see it. It's like a stack of papers. This shale layer at the bottom had to be there before the sandstone layer was laid down on top of it. It's common sense. And see that granite dike cutting through them? Well, that must have happened after both of those layers were already there. Steno's simple rule suddenly gave us the power to figure out the relative order of events. It was the first and maybe the most important step.
Okay, so Steno gave us the chapter order. We know how to read the sequence. But what was the story in those chapters actually about? Was it this epic tale of sudden, violent catastrophes, or was it something else entirely? Well, the next clue came about a century later from a Scottish scientist. And this is where James Hutton comes in. He looked at the world around him. He saw rivers slowly carving out valleys, and he saw sediment slowly building up in lakes. And he had this totally revolutionary thought. What if these small, slow changes we see happening today are the exact same processes that shaped the entire ancient Earth? In his entire philosophy, this groundbreaking idea can be boiled down to this one powerful phrase. It basically means that to understand Earth's deep, deep history, you don't need to imagine some world-ending catastrophe. No, you just need to look at the slow, steady processes that are happening all around you right now. He called this the principle of uniformitarianism. And what it suggests is that Earth's history wasn't written in a few short, violent bursts. Instead, it was the result of these slow, relentless processes acting over, well, immense stretches of time. And that was the really radical part. It implied that for all this slow change to happen, the Earth had to be incredibly, mind-bogglingly old.
And to really get how radical this was, you have to understand the prevailing theory at the time, which was catastrophism. People believed the Earth was just a few thousand years old, and its features were carved out by huge, biblical-scale events, like Noah's flood. Hutton's idea of uniformitarianism just completely flipped that script. He was proposing a planet of deep, deep time and constant, gradual change. So now we've got the order of the pages from Steno, and we've got the nature of the plot from Hutton. But there was still this huge problem. How do you know if a rock layer in, say, southern England is the same age as a layer hundreds of miles away in northern England? They look different. We needed a way to connect them. We needed page numbers.
The final piece of this puzzle came from a man named William Smith. Now, he wasn't some lofty academic in a university. He was a surveyor, a practical guy, out there digging canals and mapping the English countryside. His job forced him to understand rock layers in a very real, hands-on way, and that work led to an absolutely incredible discovery.
As Smith was digging through all these different layers, he started to notice something amazing. Certain types of fossils, they always showed up in the same sequence. You'd find one type of fossil only in the lower, older layers, and then totally different ones only in the higher, younger layers. This predictable order is what he called the principle of faunal succession.
And this was the big aha moment. Smith realized these fossils were like unique markers for geologic time. They were the page numbers. If you found a specific kind of fossil in a rock layer in one spot, and then you found that exact same fossil 200 miles away, you could be pretty darn sure that those two rock layers were from the same time period. It was a revolutionary tool for connecting the Earth's story across huge distances.
And this wasn't just some neat idea he had. Smith spent 25 years putting this principle to the test.
And in 1815, he published the first ever geological map of an entire country. It was this beautiful, color-coded map that proved that the story in the rocks was consistent, it was predictable, and it could be mapped on a massive scale.
So, let's put it all together. Once you combine these three brilliant principles from these three very different men, something incredible happens. The great big book of Earth's history was finally opened. The code had well and truly been cracked.
So let's just quickly recap this amazing journey. First, way back in 1669, Steno gave us the grammar, this simple rule that older is lower. Then in 1788, Hutton came along and revealed the plot, a grand story of slow, continuous change. And finally, in 1815, William Smith gave us the page numbers, using fossils to connect the chapters all across the globe.
And what's just so cool when you think about it is who these people were. You had a monk, totally focused on order and structure, a scientist contemplating the vastness of deep time, and a surveyor, a practical guy with dirt under his fingernails. It took all of their unique perspectives, working together across centuries to build the very foundation of modern geology.
Together, these principles gave us the tools to read our planet's past, to uncover everything from ancient oceans to the age of the dinosaurs. And it just leaves you with one final thought, doesn't it? With billions of years of history buried just beneath our feet, what incredible stories are still down there, just waiting for the next generation of codebreakers to uncover?